In this lesson, we're going to be reviewing the Pythagorean theorem. So just a reminder that a right triangle is a triangle where one of the angles is 90 degrees. And in any right triangle, we can name the sides. The hypotenuse is the side that is opposite or across from the right angle. So this would be the hypotenuse. And then the two other sides are, you can call them the legs. So that's like side A and side B, the two other sides. Now we can use the Pythagorean theorem, a squared plus b squared equals c squared, to solve for any of these unknown sides. So in this formula, a and b represent the legs of the triangle, or these you can think of them as the two sides that meet to form the right angle. And when you square both of those and find their sum, it will always be equal to the hypotenuse squared. So in this triangle, for example, triangle ABC, we can use a squared plus b squared equals c squared. And you'll see here we know a and b, but we're looking for side c. So a is 3, b is 4, and c is unknown. And when we square this, 3 squared is 9, 4 squared is 16. That will be equal to c squared. So 25 is equal to c squared. And when we take the square root of 25, we get the length of c. So c would be 5. This one doesn't have units, but if it was centimeters or meters, you would include that there. Now we can also use the Pythagorean theorem to solve for one of the legs. So in this triangle, you'll see we know the hypotenuse is 8, and we know this leg on the bottom here is 5, but we're going to solve for side f. So in our equation here, it's the two legs, so e squared plus f squared, that would be equal to d squared, because it's the legs squared and added together, that will be equal to the hypotenuse squared. So now if I plug in my values, e is 5, f is unknown, and d is 8. So 25 plus f squared equals 64. Now my goal is to solve for f. I need to get this all by itself. So I am going to subtract 25 from both sides, and I'm left with f squared equals 64 minus 25, which is 39 degrees. And very similar to up here, when we have just the side squared, we are going to take the square root. And you'll need your calculator to find the square root of 39, which is 6.24. Again, this one, if it had units, you would want to make sure you include those units. Those are basically one type of each kind of question you can see with the Pythagorean theorem. Now in this last question, this last example, we have a ladder that's placed against a wall. So here's our ladder leaning against the wall so that a painter can paint the side of a house. The ladder, the wall, and the ground form a right triangle. So here's the wall, here's the ground, and here's our ladder. The ladder is 12 feet long, and it's placed 5 feet away from the bottom of the wall. We're looking for how high the ladder will reach. So again, here, our hypotenuse is 12, and our sides are A, or our unknown, and we'll call this B. And I'm actually going to call this C so that it matches our equation. So A squared plus B squared equals C squared. So here, A is unknown, B is 5, and C is 12. So A squared plus 25 will be equal to 144. And again, I need to get a squared by itself. So I'm going to subtract 25 from both sides so that that cancels out. So a squared is equal to 119. And then I'm going to take the square root. So the square root 119 is 10.9. So that means this ladder reaches 10.9, and this question was given to us in feet, so it reaches 10.9 feet up the side of the wall. So that is the Pythagorean theorem.